Have you ever wondered what makes a building feel so warm and cozy in the winter, or nice and cool in the summer? Well, a lot of it comes down to this one really important number called the U value. In this explainer, we're going to break down exactly what a U value is, and even better, how you can actually calculate it yourself. So let's get right into it.
So here's our game plan. First, we'll start with the absolute basics. What is a U value? Then we'll introduce its friendly opposite, the R value. After that, I'll walk you through the 3 simple steps to calculate it, and then we'll dive into a real example of a wall, layer by layer. And finally, we'll put it all together to find our final U value. All right, let's jump into our first section. So what on earth is a U value? You know, in simple terms, it's just a way to measure how easily heat can pass right through something. It's really the key to understanding how efficient a building is. Okay, so the official definition is that the U value tells us the rate of heat transfer through a part of a building. You know, like a wall, a roof, or maybe a window. Just think of it like this. It measures how easily heat can get out. A high U value means heat is just flowing right through. And here is the single most important thing to remember about U value, okay? A lower number is always better. A low U value means that material is a fantastic insulator. It's great at keeping heat from escaping in the winter, and, just as important, it keeps the heat from sneaking in during the summer. Now, to really get a grip on U value, we've got to talk about its opposite, the R value. Honestly, they're like 2 sides of the same coin, and once you understand how they're related, everything else just clicks into place. Let's break this down. So, U value measures heat flow, how easily heat moves. With U value, you want a low number. Think of it like a leaky window. R value, on the other hand, measures heat resistance, how well something stops heat. And for R value, you want a high number, like a nice thick blanket. So remember, low U value is good, and high R value is good. So how in the world do we calculate the U value for something complicated, like a whole wall that has a bunch of different layers? Well, the secret is that we actually start by finding the R values first. Let's take a look at our 3-step master plan. The process is actually super simple. It's just 3 steps. Step 1, we're going to identify every single layer that makes up our wall. Step 2, we find the R value for each of those layers, and then we just add all those numbers up. And finally, step 3, to get our U value, we just take the number 1 and divide it by that total R value. Don't worry, we're going to go through this together. Okay, so that's the theory. Now, let's actually apply this to a real-world example. We're going to calculate the U value for a pretty standard wall, and we'll do it step by step. So this is the wall we're going to be working with. As you can see, it's made of a lot of different layers. We'll start from the air on the very outside, move through the brick and the concrete, and finish up with the air on the inside. It's so important to include everything, even those super thin layers of air on the surfaces, because every single layer adds to the total insulation. All right, let's get started with our very first layer. This is the thin film of air that's just sitting on the outside surface of the wall. For our calculation, we're going to use the standard value for winter conditions. Now, you don't have to pull these numbers out of thin air. They come from standard charts that everyone in the building industry uses. For this outside air film in the winter, the standard R value is 0.17. I know, it's a tiny number, but we have to include it. Let's write that down. Okay, next up is the brick on the outside of our building. This is a pretty standard 4-inch face brick. Looking at our charts again, we find that the R value for this layer of brick is 0.44. So as you can see, it gives us a little more resistance to heat flow than that air film, but it's still not a huge number by itself. Okay, let's keep moving 1 layer deeper into our wall. Right behind the brick, we've got an 8-inch thick concrete block. This is a super common building material. The R value for this concrete block is 1.11. So this one layer provides more than double the insulation of the brick layer we just looked at. We're starting to build up some real resistance now. Next, we've got something kind of interesting, a small gap right inside the wall. It's a 3/4 inch airspace, sometimes called a cavity. This is basically a little space that's filled with trapped, unmoving air. Now, this might surprise you, but a small gap of trapped air is actually a pretty decent insulator. This little space gives us an R value of a nice round 1.00. We're more than halfway through our wall now. Next up, we have another 8-inch concrete block, just like the first one. And then right after that, we have the real hero of the story, the layer that does most of the work, the insulation.
So since the second concrete block is exactly the same as the first, it also has an R value of 1.11. But now look at the insulation. It's often named right after its R value, so R17 insulation has an R value of, you guessed it, 17.00. This is the main takeaway here. This one layer gives us way more heat resistance than all the other parts of the wall combined. We are almost at the finish line. The last two layers are on the inside of the room. First, we have the plasterboard, which you probably know is drywall, and then finally that thin film of air on the very inside surface. The R value for our half-inch plasterboard is 0.45, and for the inside air film, the R value is a little bit higher than the outside one, coming in at 0.68. Great job! We have now found the R value for every single layer of our wall. Now we can finally move on to the last steps and put this all together to find our U value. So here's a little table just summarizing all the numbers we just found. You can see each part of the wall lined up with its own R value. And looking at this list, it's just so obvious how much of the heavy lifting that R17 insulation is doing compared to everything else, right? Okay, it's time for step 2 of our plan. To find the total thermal resistance for the entire wall assembly, we just need to add up all of these individual R values. When we add up all those numbers from our list, the grand total comes to 21.96. This is our total R value for the whole wall. And just so you know, an R value over 20 is really pretty good, so this is a well-insulated wall. We are on the final step. We've got our total R value. Now, to find that U value, we just have to use that super simple formula from the beginning. So we take 1 and we divide it by our total R value, which was 21.96, and the result is our final U value, 0.0455. And remember what we learned at the very start? For U values, a lower number is better. And this is a very low number, which tells us this is an excellent energy-efficient wall. And that is the entire process. We started with this complicated-looking wall, we broke it down into simple layers, and we ended up with a single number that tells us exactly how well it performs. So now you can look at your own home a little differently. Think about the materials, your windows, your roof, your walls. Which parts do you think have the highest R value and are doing the most to keep you comfortable? Thanks for joining me for this explainer. Lifting